In previous videos, we discussed the concept of antiderivatives and the concept of integration. And we had that symbol for integration. And, if we have, for example, what is the integral of x to the sixth dx? Again, what that question is asking is, what is the antiderivative of x to the sixth? And so we have to think of, well, what function, when I take the derivative of it, gives me x to the sixth. Now, really, up to this point, it's been mostly just a guessing game. We've sat there and thought, well, x to the sixth, that could be x to the seventh, plus we have our plus c. But, if I had y equals x to the seventh, then y prime would be, well, 7x to the sixth. I don't have a 7 here. So, well, what if I put in x to the 7th over 7? That might work. Y equals x to the 7th over 7, so y prime is 7x to the 6th over 7, which gives us x to the 6th. So that works out, and so this would be our answer. Okay, now, even though integration in some ways is just a guessing game, here's my function. Can I guess what the original function was when I take the derivative that gives me x to the sixth? We do want to make it a little bit more methodical. And so what we're going to do is we're going to come up with a bunch of rules and techniques to help us find antiderivatives. So it's not really per se a guessing game, it's more of an educated guessing game. And so that first rule that we're going to look at is called the power rule. So let's look at the power rule for integration. So let's say we want to take the integral of x to the n dx. So let's see what that would be. Now, if you remember, if I have f of x equals x to the n power, for the derivative, the power rule is just n times x to the n minus 1. So we want to go backwards from that. And so what we end up doing is we say, well, the integral of x to the n is going to be x to the n plus 1 all over n plus 1 plus c. And so this gives us a good rule to help us figure out the antiderivatives or to figure out the integrals of a power. So let's go ahead and use this. Let's say we have, for example, what is the integral of x to the 12th dx? Okay, so according to this rule, we're going to take whatever n is and we're going to add 1. So we're going to have x to the 13th. And then we divide by whatever that is, over 13 plus c. So that makes sense. Up here we had x to the 6th, so we added 1, x to the 7th, and then divided by 7. So that's the power rule. So instead of trying to guess, which in a way we're doing, we now can use this power rule. Let's try another example. This example is going to be a little more extensive. Let's say we want to find the integral of 3x to the 5th plus x to the 17th dx. Okay, so now we have a constant 3 times that 5x to the 5th, and then we have another adding of x to the 17th. Okay, so we can split this all up. We can take 3 times the integral of x to the 5th dx and add the integral of x to the 17th dx. And so if you are multiplying a function by a constant like 3x to the 5th, you can bring that out front. And so we'll end up with 3. Now the integral of x to the 5th, remember, we're going to add 1, so it's going to be x to the 6th over 6 plus c, and then we're going to add on to that, the integral of x to the 17th is going to be x to the 18th over 18 plus c. Okay, now the 3 and the 6 become 1/2. So we'll have x to the 6th over 2 plus x to the 18th over 18. And then these two c's, they're just constants, so we'll just bring them together and create a constant. And so there would be our antiderivative. All right. Now, you don't have to go through all these steps. I think we have the ability to go from here straight to there. I don't think that's super challenging. You know, you sit there and say, what's the integral of 3x to the 5th? It would be 3x to the 6 over 6 plus x to the 18 over 18 plus c. And then we're done. So I did these two steps in between just to kind of show how it works, but I think most students do not have a problem going from here to there. But of course, if you want to split it apart, there's nothing wrong with that. Okay, let's try another one. This one actually tends to be tricky, but once you just have to remember it, and then it's not so bad. So let's say we have, what is the integral of 4 dx? So sometimes you have to sit there and think, gosh, what do I take the derivative of in order to get 4? Well, in this case, it's going to be 4x plus c. And so that makes sense. If I take the derivative of 4x, I get 4. So it's sometimes this actually trips up students because they see that constant and they put all kinds of things down. But if you just see a constant, so we're going to call this our constant rule. Don't make it more complicated than it is, because you take the integral of 4, it's just 4x plus c. If I just have, what is the integral of dx? Well, there's a 1 in there, so it's still the constant rule, so it becomes x plus c, 1x plus c. So when you have a constant, you just got to remember that you're going to end up with 4x or 1x or whatever the constant is times x plus c. All right, now let's go on to a couple more. And these rules have to do with the sine and the cosine. So let's say we have, well, what is the integral of the cosine of x dx? Okay, so this one's interesting. We got to think, all right, well, we have the cosine of x, so when you take the derivative of it, gives us cosine. In this case, it's sine. The derivative of the sine is the cosine. So we end up with the sine of x plus c. However, what if we were to say, what is the integral of the cosine of 5x dx? Okay, so now we have that 5 in there. Okay, so got to think, gosh, what is that? What do I take the derivative of to get cosine of 5x? And so we have the sine of 5x plus c. Let me squeeze it in there. But wait a second, that doesn't quite make sense, because if y equals the sine of 5x, y prime is, well, the derivative of sine is the cosine of 5x times the derivative thing inside, which is 5. So we have this extra 5 over here. So in order to compensate that, we're going to divide by 5. Good. And let's try it with the sine. What is the integral of the sine of x over 3 dx? Now we know the integral of the sine is going to be the cosine of x over 3. And then we're going to divide it by the constant inside, 1/3. But in this case, if you remember, the derivative of the cosine is a negative sign. We don't have a negative over here. So we're actually going to have to put a negative out in front. And so we're going to end up with a negative 3 times the cosine of x over 3 plus c. Okay, so now that we've played with this a little bit, we can create our sine and cosine rules. Sine and cosine rules. The sine and cosine rules essentially say if I have the integral of the sine of kx dx, that's going to be the same as a negative cosine of kx over k plus c. And if we have the integral of the cosine of kx dx, this is going to equal the sine of kx all over k plus c. Good. So we have come up with a couple of rules. So, we have this concept of integration that we just learned. And, at first when we looked at integration, it was just a guessing game. What function, when I take the derivative, gives me this? But of course, you don't want to make it a guessing game all the time. And so we create some rules, and we'll develop more and more rules as we go along. But the first rules that are going to come up often, and we're going to use a lot, is the power rule, which is not too difficult, and the sine and cosine rule. So now that we know these rules, then we don't have to sit there and think about how to take the integral or antiderivative. We can just do it very quickly, so then we can go on to the rest of the problem, whatever it is.